Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi. Pada topik lagi lah minggu depan. Apa tu on freeway. Okey, sebelum kita mulakan dengan pembentangan by group 9, saya ada beberapa pengumuman kat sini. Yang pertama untuk makmal. Untuk makmal minggu ni kamu akan buat makmal hal laju setempat lah ataupun speed study. Itu yang pertama lah. Nanti yang kedua, ramai yang tanya saya tentang bila nak kena hantar report. So biar ni saya minta kamu hantar sebelum pergi praktikal lah. Mungkin within the last week before kamu pergi undergo di industrial training tu. Berapa bulan dalam seminggu tu lah, minggu terakhir tu lah sebelum kamu pergi praktikal. And then report tu kena buat kedua. Satu bahagian untuk material yang UK tu lah. Itu satu report, and another one report on the hal laju setempat tadi untuk speed study. And then nanti kamu untuk yang report pertama tu nanti kamu tulis kepada saya. And then yang kedua tu kepada Dr. Razwan Hanafi. Okay. Pengumuman yang ketiga untuk hari Jumaat ni kita ada talk. Saya ada jemput engineer luar lah untuk share dengan kamu tentang traffic impact assessment. Macam mana kita buat TIA traffic impact assessment di ni lah on real side lah. Nanti saya akan bagi tahu lah waktu tu. Maybe around 10 macam kita punya yang last week punya talk lah. And then so saya minta kebenaran daripada semua kita akan sambung lagi kelas untuk 1 minggu lagi lah untuk dalam minggu depan. Untuk kita sambung dengan untuk material untuk pavement yang kita akan cover untuk flexible dengan rigid pavement. Dan sebab nanti yang dua-dua soalan ni akan masuk dalam kedua-dua untuk flexible dengan rigid pavement akan masuk dalam final exam nanti. So itu kita akan saya minta kebenaran untuk kita buat kelas satu lagi untuk dalam minggu, walaupun minggu depan I think it is week 15, tapi saya minta kebenaran semua untuk kita buat satu lagi kelas, boleh ya? Kalau ada any problem kan nanti bagi tahu saya lah. Kalau katakan tak boleh nak hadir ke ataupun apa benda kan, just let me know about this. And then next class inilah Dr. Su akan take charge lah. Boleh Dr. Su?
InsyaAllah. Topik apa nama tu? Geometric design
Kapkan untuk design flexible pavement dengan rigid pavement.
Oh, flexible rigid pavement. Okey, sebab saya tengok dekat sini geometric design. Okey.
Apa nanti kita bincang semula lah.
Alright, beres.
Alright. So itu saja pengumuman daripada saya. Boleh kita mula dengan presentation by group 9. Kalau dah ready boleh mulalah on freeway. Ada ke group 9?
Ada doktor, ada.
Ada. Okey.
Sekejap ada tu, saya nak share screen je.
Okey, no problem.
Nampak slide ni?
Okey, boleh nampak. Alright.
Sebelum saya mula, saya nak tanya semua group 9 dah ada ke? Sekejap saya check. Okey.
Ada.
Okey. Saya mula.
Okey, please.
Ya, Assalamualaikum dan selamat pagi. Hari ini kami dari group 9 ingin membentangkan mengenai traffic capacity and level of service. Kita mula dengan traffic capacity. Apa yang dimaksudkan dengan kapasiti itu sendiri adalah the maximum number of vehicle in a road that can pass by a given unit time. Usually kita guna kapasiti ni dalam bentuk PCE, which is passenger car equivalent. Kita selalunya akan tukar unit jenis kenderaan tu ke dalam bentuk satu unit. Contohnya macam unit bagi kereta PCE adalah 1.0. Kemudian bagi level of service, kita takdirkan level of service sebagai maximum hourly rate that can cross a point on the road section according to the road traffic and control condition. Level of service ni kita ada 6 jenis, mula daripada A sampai ke F. Tapi biasanya kita akan gunakan level A sampai level E sahaja kerana level F telah dianggap gagal. Dan level A merupakan kondisi yang paling optimum kepada pengguna jalan raya kerana aliran trafik adalah paling lancar pada level A. Okey, bagi silibus yang kami akan present hari ini, kami akan fokuskan pada dua jenis jalan which is freeway dan juga multi-lane highway. Okey, apa yang kita boleh katakan tentang freeway ni adalah jalan yang didesain untuk kenderaan yang bergerak laju. Dan dalam freeway tidak boleh ada sebarang gangguan seperti traffic signal, intersection ataupun at grade crossing. Manakala bagi multi-lane highway, dia merupakan highway yang mempunyai lane yang lebih daripada dua. Dia boleh ada apa dia panggil tu gangguan dalam bentuk traffic light ataupun light intersection, tapi tak boleh lebih daripada 3 km. Okey, seterusnya bagi kaitan antara kapasiti dengan level of service. Bagi kapasiti dan level of service ni, kita kena rujuk kepada graf yang ada dalam slide ni, which is merelatekan macam mana kapasiti dan level of service tu correlate. Sebagai contoh, kita dapat lihat bagi level of service A, flow rate adalah tinggi. Maknanya aliran trafik adalah lancar. Manakala kalau kita tengok pada level of service pada bahagian E, aliran trafik agak rendah. Maknanya ada gangguan dekat dalam trafik dan jalan tersebut tidaklah berapa bagus. Dapat juga kita lihat kat sini ada peningkatan bagi flow rate selepas 1300 lane per hour. Maknanya semakin meningkat flow rate, semakin berkurang average passenger car speed. Maknanya lagi tinggi aliran trafik selepas 1300, maknanya kelajuan kenderaan akan semakin berkurang. Dan ini adalah speed flow curve dan LOS untuk basic freeway. Kita juga ada speed flow curve dan LOS bagi multi-lane highway. Jadi kita perlu merujuk kepada graf tersebut untuk kedua-dua jenis jalan. Okay, seterusnya bagi level of service.
Okay, level of service for freeway segment. Level of service is a qualitative measure both of operating condition within the traffic system and how these conditions are perceived by driver and passenger. Next. Okay, there are 6 factors affect the maximum flow of segment given there are 6 factors affected by maximum flow on a given highway segment. First, speed. Second, vehicle equipment. Grade, lateral clearance, lane width, and driver population. Next. So, which level of service we need to do? So, these are some information we need to refer. For level of service A, there are free flow traffic, low traffic, and high speed. For level of service B, there are stable flow and noticeable traffic. Next. And for level of service C, They are stable flow and traffic interaction. So they have a junction. And for level of service D, they are unstable flow, high density, and movement restriction. Okay, next. Right, for level of service E, they are unstable flow, lower speed, volume of nearly equal to capacity, and little freedom. And the last one is level of service F. They are unstable flow, no freedom, traffic volume can drop to zero and stop and go.
Hello. Okay, to calculate the flow rate for basic freeway section, we use this formula where VP equal to 15-minute passenger car equivalent flow rate, V equal to hourly peak vehicle volume in one direction, PHF is peak hour factor, N is number of travel lanes in one direction, FP is driver population factor with range of 0.85 to 1.0, and FHV is heavy vehicle adjustment factor. To calculate the heavy vehicle adjustment factor, we use another formula where ET is passenger car equivalent for truck buses, and ER is passenger car equivalent for recreational vehicle. To get the passenger car equivalent for truck and buses and recreational vehicle, we use the table in table 9.25. Next slide. In this table, we can see that we have the factor for ET and ER in three types of terrain, which is level, rolling, and mountainous. Next. In level terrain, the heavy vehicle can maintain the same speed as vehicle cars. Rolling terrain, heavy vehicle reduce their speed lower than passenger car, but not to travel at crawl speed. And mountainous terrain, the heavy vehicle operate at crawl speed for a significant distance or frequent interval.
For PCEs for specific upgrades. Specific grades are analyzed individually for downgrade and upgrade. Passenger car equivalent is used to represent the variant effect of mixed vehicle type saturation flow by converting a traffic stream comprising of various vehicle type into an equivalent traffic stream comprising entirely of passenger car. The segment is considered either as a grade of constant percentage or as a series of grade. For the average weight of horsepower ratio for truck is 55 to 70 kilogram per horsepower. For recreational vehicles, 14 to 28 kilogram per horsepower. Recreational vehicles is mean maksud dia ni mobile home atau tak dipandu oleh professional driver. PCE's value for truck and recreational vehicle are given in the table 9.26 and 9.27. Next. This table 9.26 for truck and bus. As we can, and this is for the table. If the upgrade tu dikira daripada dalam persen tau. Macam contoh kita dapat 2 ke 3% akan dapat untuk lepas dapat apa dia persen untuk upgrade, kita akan tengok panjang untuk tentukan nilai PCE untuk truck dan bus. Okay, next. Ni table 9.27 untuk RV. RV ni recreational vehicle. Dia lagi sikit dan tak panjang macam truck and bus. Dan cara pengiraannya lebih kurang sama. Next. Then PCE for specific downgrade. Downgrade is not severe as to cause truck to shift on lower gear. Bila tiada perubahan, dia akan jadi level tau, sama macam upgrade. Tapi bila ada perubahan, truck tu akan downshift. The car equivalent is greater than before. Tapi untuk recreational vehicle, dia dilayar sama dan tiada perubahan, sama macam upgrade. Lepas tu PCE value for truck untuk downgrade, kita boleh tengok dalam table 9.28. Next. Ni table untuk downgrade. Okay, next.
Okay, for composite grade, when a segment of freeway consists of 2 or more consecutive upgrades with different slopes, the PCE of heavy vehicles is determined by using one of two techniques. The first technique determines the average grade of the segment by finding the total rise in elevation and dividing by the total horizontal distance. Use table 9.26 and 9.27. Valid for condition where grades in all subsections are less than 4% or the total length of the composite grade is less than 1,200 meter. For the second technique is to estimate the value of an equivalent continuous grade GE. This technique should be used if any single portion of the consecutive grades exceeds 4% or if the total length of grade exceeds 1,200 meter. Truck acceleration curves are used based on a vehicle with an average weight to horsepower ratio of 90 kg per HP, which represents a somewhat heavier vehicle than the typical truck of 55 to 70 kg per HP used to determine PCE values. Next. So this is the example using average grades. Example 9.10, a segment of freeway consists of 2 consecutive upgrades of 3%, 600 meter long and 2%, 450 meter long. Determine the PCE of truck, buses and recreational vehicles on this composite upgrade is 6% of the vehicles are trucks and buses and 10% are recreational vehicles. The average grade technique can be used since subsection grades are less than 4% and the total length is less than 1,200 meter. First, calculate the total rise, average grade and total length, and then we use table 9.26 and table 9.27. The consecutive upgrade given was 2 to 3%. So the table we use 2 to 3, and the total length is 0.65 miles, 1.05 kilometer, and 6% composite upgrade. So we got ET 1.5, and then for table 9.27, consecutive upgrade also 2 to 3%, 0.65 miles, 10% composite upgrade. So we got the ER equals to 1.5. Next. And then the second technique, using performance curve. Example 9.11, a consecutive upgrade consists of 2 sections. The first of 2% grade and 1,500 meter long, and the second of 6% grade and 1,500 meter long. Trucks comprise 10% of traffic and recreational vehicles comprise 6%. Determine the equivalent grade and the PCEs. First, since the both grade exceeds 1,200 meter, average grade technique does not apply. We use the performance curve. First, point the 2% curve intersects with 1,500 meter, which is 5,000 feet, and we got the point number 1, which is 75 kilometer per hour, 0.6 miles. Secondly, Since 75 km per hour is also the speed of the truck at the beginning of the 6% grade, draw a line horizontally at 75 km per hour that intersects the 6% grade curve, and we got the point number 3. The reference distance is located on the horizontal axis, point number 4. Find the point on the horizontal axis that has a value 1,500 meter greater than at point 4. And then we got the point number 5, which means the distance between number 4 and 5 is 5,000 feet. And then the final speed for this truck found to be 37 km per hour at point 7, which is 23 miles, which is also the cross speed since the 6% curve is horizontal at that point. Finally, determine the intersection of the lines LCG equals to 3,000 meter, which is 10,000 miles, and VEG 23 miles at point number 8. Since this point lies on the 6% grade curve, the equivalent grade GE is 6%. For B, PCEs for typical trucks on specific freeway upgrades. LCG 3,000 divided by 1,000 equals to 3 km. GE we use 6%, and then from table 9.26 and from table 9.27, we got ET and ER, which is 3.5 and 4.5.
For calculating average passenger car speed, density and level of service for basic freeway section, the average passenger car speed is represented in figure 9.8 and is one of the variables that can be used to determine the level of service. Density can be computed using equation 9.21. The value of LOS can be taken from table 9.24, and there are 4 types of problems that can be solved by capacity analysis. The first one is given highway volume, number of lanes, and free flow speed, determine the level of service. The second is given highway volume, level of service, and free flow speed, determine the average speed. Number 3 is given the level of service and free flow speed, determine the hourly flow rate. And the last one is given the highway volume, free flow speed, and the desired level of service, determine the number of freeway lanes required. To solve this, it is necessary to determine the free flow speed under prevailing physical and geometric conditions. Shown below is the table 9.8 that can be used to determine the value of average passenger car speed. Next. This is table 9.24. This table can be used to determine the level of service criteria for basic freeway segment. Next. Equation 9.23 is used to compute the free flow speed. The equation is FFS equal to BFFS minus FLW minus FLC minus FN minus FID. The value for FLW can be taken from table 9.29. Value for FLC can be taken from table 9.30. The value for Fn can be taken from table 9.31, and the value for FID can be taken from table 9.32. Next, this is the table that is used to get the value for Fn, FID, FLW, and okay. Next, there are 2 equations used to find the value of S. One is FFS greater than 112 km per hour, and the other one is FFS equal or less than 112 km per hour. Next is the example for calculation. The first example is by using adjustment factor to calculate free flow speed. The first step is determine the correction factor using the appropriate table. The table used is table 9.29, table 9.30, table 9.31, and table 9.32. The second step is substitute adjustment value into equation 9.23 and solve the equation. The next example is computation of speed, density, and level of service for an extended section of a freeway. The first step is compute heavy vehicle factor using equation 9.4 to determine the correction factor for extended general freeway segment. The next step is by using equation 9.22 to determine the peak 15-minute passenger car equivalent flow rate. The third step is compute the free flow speed and density by using equation 9.32, and the last step is using figure 9.8 or table 9.24 to determine the level of service.
Okay, next is about the multi-lane highway. Multi-lane highway is a highway with at least 2 lanes for the exclusive use of traffic in each direction, with no control or partial control of access, but that may have a periodic interruption to flow at signalized intersection not closer than 3 km. This is the example of undivided multi-lane highway. So, characteristic about multi-lane highway is post limits between 60 to 100 km per hour, undivided or have a medians, located in suburban areas or high volume of rural corridors, may include two-way left turn median lane. Traffic volume of the multi-lane highway is between 15,000 to 40,000 per day. Volume up to 1,000 per day with a great separation with no cross median access. Traffic signals at the major intersection are possible. So the last is partial control of access. Next, this is the equation to find the density. The question is VP over per S, which is VP is the flow rate of the height of the vehicles, and S is the average passenger car travel speed. Next, the figure shows to find this table. It shows the speed flow curve with the level service of criteria for multi-lane highway, which is to find the flow rate based on the laws A, B, C, D until F. Next. So this is the definition of loss. Loss A. Loss A is represent the free flow at low concentration with no restriction due to the traffic condition. Loss B is the lower limit of which is often used to the design of rural highway is the zone of stable flow with more marked restriction. Loss C denotes the zone of stable flow with more marked restriction on the driver's selection of speed and with reduced ability to pass. Reduce our speed when exceed 80 km per hour. Next. Loss D. Loss D is the reflect later freedom for driver maneuverability. Loss E. Low operating speed and volume near or at capacity which the area is of unstable flow. Loss F is provided by the familiar traffic jam with the frequent interruption and breakdown of flow.
Loss stands for?
Huh?
Loss 2 stands for apa?
Level of service.
Alright. Continue.
Okay, next.
So here the calculation for the flow rate for multi-lane highway. So basically it's the same as free lane highway, but next please. There are two situations need to be considered. First, extended general segment. So the terrain level is the terrain is level, rolling or mountainous. The second situation is specific graded, so it defined by segment. So the first point, value of ET and ER can be obtained on the table 9.25. So on the specific graded is two. There has two grade, which is upgrade. So the value of ET and ER can be obtained from the table 9.26 and 9.27 as the downgrade. Value of ET can be obtained on the table 9.28 and the RV are treated as they were on the level terrain. So next. So to determine the grade of highway profile, several situations are possible and each involving different computational technique. So first, highway profile is a constant grade compute by using G equal to 100 times H over L, height over length. Okay. So second, segment length is below than 1,000 1.2 meter. No. Sorry. So 1,200 meter or graded 4%, less than 4%. So compute using average grade. So 3 segment length is 1,200 meter or above grade 4%. Use truck performance curve. Next. Thank you.
Okay, calculating the average passenger car speed, density and level of service for a multi-lane highway. Next. Okay, first step is to compute the value of free flow speed using the equation 9.25, just like I show here. Next. Our second step is to compute the value of flow rate in unit parsec per hour per lane using the equation 9.22. Next. For the third step is to construct a speed flow curve of the same shape as shown in the figure 9.15 and then interpolate between two curves that span the value of FFS obtained in step 1. Next. Step 4 is to determine the value of average passenger car speed. Read out from the value of flow rate obtained in step 2 to the intersection of the FFS curve. We need to remember that if flow rate is 1,400 parsec per hour per lane or less, the value of S is the same as that of FFS. Step 5 is to compute the density using the equation 9.21. The last step is to determine the level of service. Use the value of density compute in step 5 and enter the table 9.33. Next is example of calculation. So the question is a 960 meter segment of 5.2 kilometer 4-lane undivided multi-lane highway in suburban area is at a 1.5% grade. The highway is in level terrain and lane widths are 3.35 meter. The major free flow speed is 73 km per hour. The peak hour volume is 1,900 vehicle per hour. Peak hour factor is 0.9 and there are 30% trucks and 2% RVs. Determine the level of service, speed and density for upgrade and downgrade. So the first step is to determine the free flow speed, but we don't need to find it because it has given already in the question, which is 73 km per hour. And then the second step is to determine the flow rate using the equation 9.22. So we just input the given data in the formula of flow rate and then we will get 1,129 parsec per hour per lane. And then we need to find the average speed, but since our flow rate is below than 1,400 parsec per hour per lane, so our average speed is same as free flow speed, which is 73 km per hour. Next. So, and then we compute the density from equation 1.21, flow rate divided by average speed, and then we will get 15.5 parsecs per kilometer per lane. And then we can refer to table 9.3. We can determine the level of service. So by the given the value of we get from density and then free flow rate, flow rate, we can determine the loss of refer to table 9.23. Next. And then we can use the same step to determine the density and loss of service for the upgrade direction. Just that thing. Next.
For the summary, highway and traffic engineers are frequently engaged in evaluating the performance of different facilities of the highway system. These facilities include freeway segments, intersections, ramps, and other highway elements. The level of service is a measure of how well the facility is operating. It is both a qualitative measure of motorist perceptions of the operational condition existing on the facility, as well as a measure of the density of vehicular travel. Next, a primary objective in highway and traffic engineering is to provide highway facilities that operate at levels of service acceptable to the users of those facilities. Regular evaluation of the level of service at the facilities will help the engineer to determine whether acceptable conditions exist and to identify those locations where improvement may be necessary. Then levels of different operating conditions are assigned to varying levels of service, ranging from level of service A to level of service F for each facility. The different levels of operating condition are also related to the volume of traffic that can be accommodated by the specific component. Hence, this amount of traffic is also related to the capacity of the facility. Lastly, this chapter has described the procedure where determination of the level of service on a freeway section as presented in the Highway Capacity Manual 2000. The procedures are based on the results of several major studies from which several empirical. That's all from us. Thank you.
Thank you. Terima kasih kepada kumpulan 9 for the nice presentation. Cuma saya nak tegur apa ni tadi, LN tu bukan lawn. LN tadi lane. L-A-N-E, lane. Lorong. Ada kamu sebut tadi apa? Lawn, bukan lawn. Memanglah kalau untuk mathematics LN tu dia stand for lawn. Tapi kalau untuk kita punya ni LN tu stand for lane. Satu lagi I'm not sure, maybe Dr. Su boleh betulkan. Selalu kita tak sebut loss, kita selalu LOS lah. Dia abbreviation for level of service. Kita tak sebut loss B, loss A. Agak inilah. So selalunya kalau traffic engineers dia akan sebut LOS.
Betul.
Okay, so kita sambung dengan next group.
Thank you, Doktor.
Terima kasih. Boleh kita sambung dengan next group?
Boleh atau boleh?
Boleh.
Boleh lah.
Sekejap, Doktor tengah pasang slide.
Boleh start, Doktor?
Boleh. Sila.
Assalamualaikum warahmatullahi wabarakatuh. I bid to Doctor and to all my friends. We are from Group 10 and our topic today entitled Capacity and Level of Service for Freeways and Multi-Lane Highways. Next. This is our group member. Next. Okay, let's move on to the first part, which is for freeways. Next. Okay, a freeway is a divided highway with full access control and 2 or more lanes in each direction for the exclusive use of moving traffic. To maintain a continuous flow of traffic, signalized or stop control at grade intersections or direct access to adjacent land use are not permitted. The capacity of a freeway also is the maximum sustained 15-minute rate of flow expressed in passengers cars per hour per lane, which can be accommodated by a uniform freeway segment under prevailing traffic and roadway conditions in one direction. A freeway consists of three elements, which are basic freeway section, weaving areas, and ramp junction. Next. For the LOS for freeway segments, level of service qualitatively measures both the operating conditions within a traffic system and how these conditions are perceived by drivers and passengers. It is related to physical characteristics of the highway and the different operating characteristics of the highway. There are principal factors affecting the level of service of a highway segment, such as lane width, which is traffic flow tends to be restricted when lane widths are narrower than 3.6 meter. Second is the lateral clearance. The effect of lateral clearance is more pronounced for the right shoulder than for the median. Next is the vehicle equivalent. The presence of vehicles other than passenger cars such as trucks and buses reduce the maximum flow on highway. Next is about the grade. The effect of grade depends on both the length and slope of the grade. And lastly is the driver population, which is under ideal conditions. The driver population consists primarily of commuters. Next.
There are 6 levels of service, LOS, of operating operations. First, starting with LOS A, as we can see in the picture, there is free flow operations in which vehicles are completely unrestricted in their ability to maneuver. Next is LOS B. Traffic is moving under reasonably free flow conditions and free flow speeds are sustained. So at this level, flow operating space beginning to be restricted by traffic conditions, where there is reasonable freedom to select speed lane. The lower limit at this level is the lowest speed and highest volume, which then associated with service volume in the design of rural highways. Next. LOSC, speeds are at or near the free flow speed, but freedom to maneuver is noticeably restricted. In this level, drivers are restricted regarding speeds, lane changes, and overtaking maneuvers. A relatively satisfactory operating speed still can be obtained with service volume suitable for urban design practice. For LOSD, speeds can begin to decline slightly and density increases more quickly with increasing flows. In this level approaches unstable flow because the operating speed is tolerable but considerable affected by changes in operating conditions. Drivers also have little freedom to maneuver. Next. LOSE, operations are volatile because there are virtually no usable gaps. In this level can be determined by volumes near highway capacity. So the typical speeds used in this level are approximately 50 km per hour. Flow is unstable and there may be stoppages of short durations. Lastly, LOSF, operation is under breakdown conditions in vehicular flow. These conditions prevail in queues behind freeway sections, experiencing temporary or long-term incapacity. In short, level of service A is the highest, while level of service F is the lowest. Next.
Next. Next one. Okay, next one is the passenger car equivalent, as known as PCE. PCE is metric used in engineering to assess traffic flow rate on a highway. PCE for truck can be defined by 3 grade condition. First one is general freeway segment, second one is specific upgrade, and the last one is freak downgrade. PCE by truck can be affected by type of terrain. Next one. For the type of terrain, there are 3. First one is level terrain, rolling terrain, and mountainous terrain. For the level terrain, condition of grids and horizontal alignment allow truck to maintain same speed with car. This one is rolling terrain, condition of grid and horizontal alignment, which cause truck to reduce its speed below car, but not in crawl speed. This means that the road is slightly inclined. The last one is mountainous terrain. combination of grades and horizontal alignment cause truck to travel in cross speed in significant distance. Which means that the road is in inclined position. This one. So the next one is a standard general freeway segment. It is first grade condition. So, for the characteristic is occur when a single grade is not too long or steep to have significant impact on capacity. Grades of at least 3% and less than 400 meter. The last one is grade less than 3% and less than 800 meter. For the PC value, depend on type of terrain as table as shown in table 9.25. Is the factor and type of terrain. So the factor is truck and buses, as well as EP, and recreational vehicle, or as well as SER. And the type of terrain have level, rolling, and mountainous. This one. So the next one is specific upgrade. The characteristic is freeway grade of 3% or more and longer than 400 meter. A grade of at least less than 3% and longer than 800 meter. The average weight to power horse is for truck 55 to 73 kilogram per 1 horsepower, and for car is 14 to 28 kilogram per 1 horsepower. Which means that a truck need more horsepower than a car to move them. For table 9.26 and 9.27, it gives a PCE volume for truck as well as EP, and for the commercial vehicle that travelling on specific upgrade for different grades and different percentage of truck within the traffic stream. Next one. So this is table 9.26. It is for truck, PCE for the truck. And next one. This table 9.27. PCE for the RV, recreational vehicle. So the last one is PCE for specific downgrade. If the downgrade is not severe, treat as if they were on level segment. And if the downgrade severe, the effect on car equivalent is greater, shown in table 9.8. This is for PCE for the truck or downgrade. As the truck have to downshift, the effect on car equivalent is greater. The downgrade severity depend on whether the truck require to shift gear or not.
Thank you, Carol. Everyone can hear me? Hello?
Yes, yes.
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 Thank you.
Thank you. So for my next part, I will be explaining the PCE for composite grades. So what is actually a composite grades? It is a freeway segment that consists of 2 or more consecutive upgrades with different slopes. So in order to determine PCE on composite grades, there are 2 methods, which is the first method is the average grade method, and the second method is the performance curve method. So next slide. So for the first method, which is the average grade method, so we need to satisfy the condition first. So when to use it is when the grade in all subsection, which means the 2 segments are less than 4%, and the total length of the composite grade is less than 1,200 meter. When the condition is satisfied, then we can use this method. So next slide. So how to use it? So first, we need to determine the average grade of the segment, which is equals to the total rise in elevation divided by the total horizontal distance. So and then we later then use the average grade with table 9.26 and 9.27 to get the truck PCE and the recreational vehicle PCE. I will show the example later. So next slide. This is table 9.26. I believe Khairul already mentioned this part. So next slide. Next slide also. It's already mentioned. So for the first example, which is to use the average grades method, let's read the question first. A segment of freeway consists of 2 consecutive upgrades of 3% and 600 meter long and 2% and 450 meter long. So we need to determine the PCE of truck and recreational vehicle on this composite upgrade if 6% of the vehicles are truck and buses and 10% are recreational vehicle. So in order to solve this problem, we need to identify what kind of condition So in this case, the average grade technique can be used because the subsection grades are less than 4% and the total length of both segment is less than 1,200 meter. So first, as I mentioned before, we need to find the total rise. Total rise is the grade percentage times the distance. So as you can see in the slide, 0.03, which is the percent for the segment times for the length, and then we plus for the both segment, and then we get 27 meter. And then the average grade is the total rise divided by the total distance, and then we get 2.6%. The total length is just the total length divided by 1,000 to get in kilometer. So and then next slide. So to use table 9.26, as you can see, our upgrade is 2 to 3%. And I forgot to mention that this table is in mile, so we need to convert it into kilometer. So based on our answer before, 1.05 kilometer is equal to 0.65 miles. So our length is within 0.5 up until 0.75. And also mention that the percentage of trucks and buses is 6%. So we get our ET is 1.5. So next slide. And then our grade is 2 to 3%, same as before. Our grade is 2 to 3%. Our length is far greater than 0.5 miles. And our percentage of RV is 10%. And then we get our ER is 1.5. Next slide, please. So for the second method, there is also this condition that we need to satisfy first. We use it if any single of the consecutive grade exceeds 4%. And this means that if there are two segment, if any of the single segment exceed 4%, then we need to automatically use this method. And also if the total length of grade exceed 1,200 meter, then we use this performance curve method. So next slide, please. So this is the performance curve. I think I will explain it later using the example. Next slide, please. So this for the second example, a consecutive upgrade consists of two sections. The first of 2% grade and 1,500 meter long, and the second of 6% grade and 1,500 meter long. Trucks comprise 10% of traffic and recreational vehicle comprise 6% area. Determine the equivalent grade, and B, the PCE, which is the entry speed is 88 km per hour. So next slide. So first, we need to find the equivalent grade, right? Which is the GE. So we need to identify first what is our condition. So since length for both grades exceed 1,500 meter, and then we need to use this performance curve method. So there are a total of 4 steps. I think it might be clear if I don't know how. Never mind. Just can you go to the next slide, please? So wait, need to use my cursor to show it, but I think I just no, go previous slide, please. So there is a total of 4 steps. So we first need to find the point on the 2% curve that intersect with length that is equal to 1,500 meter. So and then we need to identify it as point 1, and then we pull a horizontal line to the left at the end of this first grade, that is point 2, and then we get 75 km per hour. So the second step is to draw a horizontal line from point 2 to intersect the 6% curve and pull vertically to get reference distance, that is the point 4. And then we add 1,500 meter from point 4, and we will get point 5. We pull vertically upward to intersect with the 6% curve, which is point 6, and draw a horizontal line to get the speed at the end of the 6% grade, which is point 7. Then the last step will determine the intersection of line LCG, that is 3000 meter, and VEG, that is equal to 37 km per hour, that is 0.8. Since the point lies on the 6% grade curve, the equivalent grade GE is 6%. So next. So we need to find the PCE with the entry speed at 8 km per hour. So we already calculated our length is 3 km and our equivalent grade is 6%. Then we use table 9.26. Next slide. We use table 9.26, which our upgrade is within 5 to 6%, and our length is more than 1 mile, and our percentage of truck is 10, and then we get our ET is 3.5. And then next slide. Our grade is more than 5%, and then our length is more than 0.5, and our ER is 4.5. Yeah, next slide. Thank you.
Okay, so this is about average passenger car speed, density, and level of service for basic freeway section. For capacity analysis, we need to compute VP, which is the flow rate, to find average passenger car speed, and then compute the density and find corresponding LOS in the table. Next. Okay, this is the free flow speed equation, which is we have base free flow speed minus the adjustment for lane width, right shoulder lateral clearance, number of lanes, and interchange density. Next. Okay, for average passenger car speed, we have two equations, and if the flow rate is lower than 5440 minus 48 FFS, so we take S as the same number with the FFS. But if the flow rate is higher than 5440 minus 48 FFS, we need to use these two equations, which is at the left side. If the FFS is higher than 112 km per hour, we use the equation at the left side. And if the FFS is lower than 112 km per hour, we use the equation at the right side. Next. Okay, for the adjustment of lane width at the left side. So if the lane width is 3.6, below 3.6 meter, we use the adjustment as the table below. So if the value of the lane width is in between this number, we need to use the interpolation to get it. But if the lane width value is higher than 3.6, so we just use 0 as the adjustment. Same as the right hand side. So it is for right shoulder lateral clearance. So if the right shoulder clearance is below than 1.8, we use the value at the table below. Next. And this is the adjustment for number of lanes. So if the number of freeway lanes in one direction is below 5, we use the table value for at the left side, and for the interchange density, if interchange per kilometer is higher than 0.3, we use the table at the right side. And next.
Okay, moving on to the example 9.12. So for this example, they give us the base free flow speed and the data of the freeway section. The first step is to apply the correction factors for the data of the freeway section, and then we substitute the base free flow speed and the adjustment made into the free flow speed equation, and then we get 94.3 km per hour. Next. For example 9.13, we need to determine the level of service based on example 9.12. If the flow rate is 725 passenger car per hour per lane, we use
we use the density equation to find the density to refer to the LOS table. So since our VP is less than 5,440 minus 40 FFS, we can assume that the speed is equal to the free flow section, and then we can substitute it into the density equation, which is VP over S 725 over 94.13 to get 7.69 passenger car per kilometer per lane. And then we can refer the graph or the table in the next slide. Next. So based on this table, the density in the last slide is 7.69, and then we can see at the free flow speed at 90 km per hour that 7.9 dense passenger car per kilometer per lane is in between the 7 and 11, and we can state that the LOS is B for that session. Next. The next example, the first step is to use the table 9.25 at the top right. Because the grid is less than 3%, we know that the road is level, and then we substitute the factors into the heavy vehicle factors to get 0.94, and then we compute the flow rate using flow rate equation, and we get 1,251 passenger car per hour per lane. And after we make the correction factors, and we get the base free flow speed from the data, we can compute the free flow speed, which is 100 km per hour. And since the flow rate is less than 5,440 minus 48 FFS, we assume the speed is equal to free flow speed, and then we use density equation, and we get the density is 12.51 passenger car per kilometer per lane. And then based on that, we can refer to the table, and we find the LOS is C. Next. Next example 9.15. We need to determine the number of lane for LOS. First step is to determine the PCE equivalent, passenger car equivalent of trucks and RV based on table 9.26 and 9.27. We get 2 for trucks and 4.0 for RV. And then we substitute it into the heavy vehicle factor equation, and we get 0.86. And then for the free flow, for the flow rate, we need to use the flow rate equation, but we need to take into account that we are finding the required number of lanes. So we use n equals to 2, n equals to 3, and n equals to 4 respectively. And we get 1,834 passenger car per hour per lane for number of lanes equals to 2, for n equals to 3, flow rate is 1,233 per passenger car per hour per lane, and n equals to 4, the rate is 917 passenger car per hour per lane. Next step, we use the free flow speed equation and the adjustment made, and then we get the own free flow speed for each lanes, and then we compute the speed. Okay, this one, since the flow rate is greater than the 5,448 minus 48 FFS, we use the equation stated previously, and the free flow speed is less than 112. Okay, so when we plug in all the values, we get the speed of 103.4 km per hour. And then we can calculate the density based on that. When we substitute it out, we get 17.5 passenger car per mile per lane for 2 lanes. And we calculate also for the 3 lanes and the 4 lanes. So that we can determine the LOS based on the density. So for 2 lanes, we get LOSD. For 3 lanes, we get LOSC. And for 4 lanes, we get LOSB. And then since the LOS is C is stated in the question, we can use the 3 lanes. Next.
Next. Moving on to, I will explain about multi-lane highways. As we know, a highway is a public road, especially a major road connecting 2 or more destinations. Multi-lane highway is a highway with at least 2 lanes for the exclusive use of traffic in each direction, with no control or partial control of access. But that may have periodic interruption to flow at signalized intersection not closer than 3 km. They are typically located in suburban areas leading to central cities or along high volume rural corridors that connect to cities or important activity centers that generate a considerable number of daily trips. Next. Next, I will share the characteristic of multi-lane highway. First, multi-lane highways generally have posted speed limits between 60 km per hour and 100 km per hour. Second, they may be undivided or include medians. So just for sharing, the median is the reserve area that separate opposing lanes of traffic on divided roadways, such as divided highways, dual carriageway, freeways, and motorways. The term also applies to divided roadway other than highways, such as a major street in urban and suburban areas. The traffic volume generally varies from 15,000 to 40,000 vehicles per day. It may also go up to 100,000 vehicles per day with great separation and no cross-median access. Also, the characteristic for multi-lane highways are traffic signals at major intersections are possible for multi-lane highways, which facilitate partial control of access. Next. This type of multi-lane highway, first is a divided multi-lane highway in a rural environment. Second is divided multi-lane highway in a suburban environment. The third one is undivided multi-lane highway in a rural environment, and the lastly is undivided multi-lane highway in a suburban environment. Next.
Hello, Azhar. Oh, wait, doktor kejap. Ya, doktor. Sekejap. Dia disconnect.
Kita tak.
Rasanya skip part ni dulu boleh ke? Kita jadi datang balik.
Boleh. Teruskan.
Boleh ya?
Boleh.
Okay, for heavy vehicles adjustment, if there is significant recreational or weekend traffic, the value is reduced. The presence of heavy vehicles in traffic stream decrease the free flow speed, and because base condition is equals to FHV equals to 1.0, it allow a traffic stream of passengers cars only. Then traffic volume must be adjusted to reflect an equivalent flow rate expressed in passengers car per hour per lane. This can be accomplished by applying the heavy vehicle factor. Adjustment for heavy vehicles in traffic applies to three types of vehicles, which are trucks, recreational vehicles, and buses. So this is a formula of heavy vehicle factor. Finding FFV require you to find equivalent truck factor, which ET, and recreational vehicle factor ER to compute the adjustment factor. Two situations need to be considered. The first one is a standard general segment type of train. For an extended general segment analysis, the train of highway must be classified as level, rolling, and mountainous. And value of ET and ER can be obtained in table 9.25. Next one is specific grades. Any highway grades of more than 1.6 km for grade less than 3% or 0.8 km for grades of 3% more should be considered as a separate segment. Analysis of such segment must be considered the upgrade and downgrade condition. So value of upgrade, ET and ER can be obtained in table 9.26 and 9.27, while value for downgrade, ET can be obtained in table 9.28. To determine the grade of highway profile, three situations are possible. The first one is highway profile is in constant grade. We can use equation 9.24. And highway profile consists of two or more segments of different grade. So the value of a grade for analysis segment is determined for two possible conditions, which are the first one is segment length is less than 1,200 millimeter or grade is less than 4%. We can use the equation 9.24. And segment length is more than 1,200 millimeter or grade is 4%. We can use figure 9.13 and performance curve solution. Next.
For average passenger car speed, density and level of service, the following steps are used to calculate the average passenger car speed. Step 1, compute the value of free flow speed by equation 9.25. Then step 2, compute the value of flow rate. Step 3, construct a free flow speed flow curve of the same shape. Then interpolate between two curves that span the value of free flow speed, which obtained in step 1. Then we moving on to step 4, determine the value of average passenger car speed, read out from the value of flow rate obtained in step 2 to the intersection of free flow speed curve. Note that if the V is 1,400 per sec per hour per lane or less, the value of S is the same as that of free flow speed. Step 5 is compute the density. Step 6 is determine the level of service. Use the value of density compute in step 5 and enter in table 9.33. Next. So in example 9.16, determine the level of service, speed and density for upgrade and downgrade. Okay, first
we compute the flow rate using the equation 9.4 and 9.22. Then we compute the free flow speed. Since the free flow speed is measured, no computation are required. Then we estimate. Then we compute the free flow speed. Then we can estimate the speed and then the density. Using the equation 9.2. Then determine the level of service. Refer from the table 9.1. 1.90. Next.
Bobby, bagi Azhar. Azhar.
Sekejap sorry. Okay, so this is the LOS for multi-lane highway. So there are three performance characteristics that can describe LOS for multi-lane highway. So that is flow rate, which is passenger car per hour per lane, density and average passenger car speed. So this characteristic can be seen in this equation. So although speed is a major concern for drivers, freedom to maneuver within the traffic stream and the proximity to other vehicles are also important. So LI's criteria are listed in table 9.33 in terms of maximum density, average speed, and maximum volume to capacity ratio. So the figure 9.15 shows LOS boundaries as loop lines, each corresponding to a constant value of density. Next. So for this multi-lane highway, we have level of service from A through F. So the level of service from A to F can be seen and definition in the table. Next. Okay, so for calculation, we have flow rate. So we need to determine the flow rate to get the FFS, free flow speed. So the flow rate in passenger car per hour per lane for a multi-lane highway is computed using equation 9.22. So the hourly flow rate must reflect the influence of heavy vehicle, the temporal variation of traffic flow over an hour, and the characteristics of the driver population. So these effects are reflected by adjusting hourly volumes or estimates typically reported in vehicles per hour to arrive at an equivalent passenger car flow rate in passenger car per hour. So the equivalent passenger car flow rate is calculated using the heavy vehicle and peak hour adjustment factor that is reported on a per lane basis. So peak hour factor represent the variation in traffic flow within an hour. Observations of traffic flow consistently indicate the flow rates found in the peak 15-minute period within an hour, so are not sustained throughout the entire hour. Next. So we have driver population adjustment factor. That typical value range 0.85 to 1, but for commuter driver, we use 1.0. Next.
Okay, for the summary, before this slide, Ayana, hello.
Yeah.
Okay. For the summary, highway and traffic engineers are frequently engaged in evaluating the performance of different facilities of the highway system. These facilities include freeway segments, intersection, ramps, and other highway elements. The level of service is measure of how well the facility is operating. It is both qualitative measure of motorist perception of the operational condition existing on the facility, as well as the measure of the density of vehicular travel. A primary objective in a highway and traffic engineers is to provide a highway facility that operate at level of service acceptable to the users of those facilities. Regular evaluations of level of service at the facilities will help the engineers to determine whether acceptable condition exists and to identify those locations where improved elements may be necessary. Next. Level of different operating conditions are assigned to varying level of service ranging from level of service A to F for each facility. The different level of operating condition are also related to the volume of traffic that can be accommodated by specific component. This amount of traffic is also related to the capacity of facility. Thank you. This was for verse.
Thank you very much, group number 10, for a very nice presentation. Dr. Su nak komen ke? Do you want to summarize ke, nak conclude ke?
Thank you for both of the group. Siapa buat apa nama tu PowerPoint apa presentation yang for group 10 ni?
Buat sekali tu.
Ya. Cantik.
Canva. Thank you.
Okay, saya tak ada apa banyak sangat nak itu pun sebab actually hari ni punya topik tak banyak sangat kan. Cumanya just want to recap balik. So this today kita discuss pasal the level of capacity, the level of service for freeway and multi lanes kan. Kalau masih ingat last week kita dah discuss pasal level of service juga kan, pasal apa nama tu, how to determine the level of service and then how to upgrade the level of service kan. So kalau macam kita dapat level of service C, katakan how to upgrade to B. Okay, so today you discuss on the level of service to itself and also it's for freeway and multi-lanes. Freeway ni kalau kita punya condition macam dekat highway tu lah, selepas kita masuk highway tu once we get once habis saja di acceleration lane tu, kita masuk dekat yang maknanya yang kita boleh buat full speed lah. Kalau apa level of service A tu kalau highway tu design for 180, so you can go to 180 kan. Itu kalau for level of service A, and then the capacity tadi you dah discuss juga and you dah define juga what is the capacity. So the capacity tu maknanya dia low kan, low capacity, so you can go to 180 ke kita punya highway 110 kan, so you can go 110. Tapi bila lebih banyak vehicle, so your apa nama tu panggil kelakuan, so you have to apa nama tu dipengaruhi oleh kenderaan yang lain kan. Okay, so you have talk about the traffic tadi, flow rate. Okay, so kalau flow rate macam tadi saya cakap, kalau flow rate less than capacity, so you can go well, so smooth, you can get to the apa nama tu maximum. Ataupun kalau flow rate tu at or near the capacity, so you will apa nama tu face delay or congestion. So untuk delay and congestion ni maknanya kita punya level of service tu dah turun kan. So kalau macam kita discuss last week, so macam mana kita nak upgrade balik, so either we apa nama tu introduce passing lane kan, ataupun some other way lah. So lepas tu we are talking actually about the capacity analysis which involve quantitative evaluation of the capability of that road section. Okay, macam kita hari ni freeway and multi-lane to carry traffic. Okay, so it depends on the procedure to determine the maximum flow of traffic. So yang you all discuss tadi tu basically is about that lah. Alright, so the maximum speed that can be achieved on a uniform section, okay, of a highway yang tadi tu is called the mean free speed kan. Alright, so it depends on physical characteristic of the highway jugalah. Alright, so normally it can be achieved when traffic demand volume low lah. So less than, tadi ada discuss kan berapa passenger car per hour per lane kan. Alright, and then so macam tadilah I said, bila interaction tu increase, the motorist akan influence by action of others. Sebenarnya kalau macam kenderaan depan tu slow, so you have to slow down juga kan, and then it will create congestions and delay kan. So basically kita ada freeway ni sebab kita nak the flow tu smooth lah. Alright, so I think tak banyak pun. So as I said tadi, kita dah bincang last week how to determine, how to upgrade, and then for this chapter kita discuss how to get the free flow speed kan, so that kita punya traffic tu smooth. So it can be determined in two ways. Okay, kalau you perasan, so satu with field measurement, okay, and then satu lagi by formula lah yang you dah discuss tadi. So I think itu je. So with this week kita dah finish on the traffic punya topics kan. Kalau next week kita nak start dengan pavement design. So I think itu je lah Dr. Izzy. You have anything to add up?
Okay, thank you very much Dr. Su for the wrap up. Saya tak ada apa nak tambah. Cuma mungkin kita akan tengoklah dalam hari Jumaat ni. So I think we're going to have seminar lah, webinar on this coming Friday on traffic impact assessment. Nanti kamu boleh tengoklah apa yang kita belajar hari ni, and then yang last week apa semua tu, macam mana kita nak implement on the real side dalam keadaan sebenar lah nanti. So nanti one of the engineers tu akan explain lah. So engineer tu akan explain nanti kepada kamu macam mana sebenarnya, macam mana kita nak relatekan, nak kaitkan dengan apa yang kita belajar hari ni dengan keadaan sebenar dekat tapak nanti. Itu kita akan tengok ke depan lah. So thank you very much Dr. Su. So saya tak ada apalah. Saya ingat mungkin Dr. Su pun dah explain well. Dah summarize well apa yang kita dah belajar hari ni. Cuma at the end of the day, kalau kamu ingat balik dalam chapter berapa, mungkin dengan Dr. Razwan Hafiz dulu, dan kamu belajar tentang tentang traffic study, introduction to traffic study. Sebenarnya yang ni pun sama jugalah, kita kaitkan dengan speed, flow and density lah. Tiga perkara tu adalah berkaitan dengan best fundamental of the traffic flow study. Memang banyak je tadi saya dengar kamu cerita tentang speed, density, flow, lepas tu level of service adalah flow divided by density definitely B over C, saya tak ingat macam tu lah. So tak apa, nanti kita akan tengok. Sorry Dr. Su,
tambah sikit hari Jumaat ni dia akan dengar on traffic impact assessment.
Betul.
So yang you all discuss all this beberapa minggu ni, yang ini untuk condition highway yang sedia ada. So kalau macam yang traffic impact tu dia untuk yang if you are to propose new highway juga. So nanti it's good lah for you to compare macam mana how it be done kan. So macam yang sekarang ni you study on the characteristic of highway yang sedia ada. So how you, if you want to upgrade ke macam mana kan. So yang tu nanti how you want to propose new alignment ke macam mana, I think Macam tu lah. So do look forward for the talk nanti. Okay.
Okey. Saya ingat itu sajalah untuk hari ini. Cuma saya nak minta tolong semualah. Sekarang ni kalau dalam dalam meeting ni kita hanya ada 25 orang aja ni. Kita ada 25 orang saja. I don't know. Suppose kita ada 100 orang. So saya nak minta tolong kamu semua bagi tahu lagi 70 ni. Tolong bagi sebab kenapa tak datang kelas hari ini. Sebab kalau 30 orang ni boleh bangun, before 9 AM in the morning, why the rest cannot, be here? Except, I think, just one student, Hizami, yang text saya pagi ni sebab dia kata dia ada interview. So, yang tu tak boleh nak elak lah macam mana. So, saya nak minta tolong semua, tolong bagi tahu kawan-kawan yang lain yang tak datang hari ini, minta tolong text, bukan kepada saya, tapi dalam grup saya. Dalam kita punya grup WhatsApp Highway KH 3333 tu, Highway Engineering, kenapa tak datang kelas hari ni. Otherwise, kalau saya tak dapat 70 reason why the rest didn't come to class today, saya tengoklah sama ada saya akan potong markah mereka untuk final exam ataupun yang 30 ni pun akan tiba juga. Tolong bagi tahu. Saya tak nak PM tepi, saya tak kalah yang PM tepi ya. Beritahu kawan-kawan lain yang 70 orang ni, saya dah print screen lah kita punya kelas ni. Saya adalah dalam 30 orang, 30 orang tadi, 30 something. Tolong sampaikan kepada yang 70 lagi tu, please ask them to text in the group lah. I'm expecting that we are going to receive around 70 reasons why they do not come to class. Okay? Boleh? Saya minta tolong sampaikan kepada kawan-kawan yang lain ya.
Baik, Doktor.
Alright, thank you very much. Terima kasih banyak semua. Alright, so I'll see you on Friday ya. On Friday at 10 AM in the morning. Kita gunakan Teams juga lah. We're going to use the same channel using Microsoft Teams. Okay, thank you very much.
Hello, Doktor. Afi ada soalan.
Doktor, nak confirmation balik final exam 12 hari bulan 7 yang ikut jadual SMP ya?
Betul.
Okey, terima kasih Doktor.
Tak ada masalah kan? Tak apa, exam tu take home exam, no problem. Tapi
cover chapter apa ya Doktor?
Cover daripada first week lah. Sebab ni tak apa, nanti saya akan text dalam group. No problem about this.
Doktor, saya nak tanya.
Yes.
Doktor, pre-screen attendance tu masa awal masuk ke last kelas dah nak habis? Sebab ada kawan saya, dia present sekali tapi dia orang keluar sebab ada sakit perut, ada mak panggil. Macam lah.
Okey, tadi dalam yang saya pre-screen ada 35 orang. Tak apalah, yang ada tu nanti bagi tahu saya, tak apa. Sekarang ni dalam meeting kita ada dalam 28 lah. Minus myself dengan Dr. Su. The rest ada 28. But I think before this kita ada around 33. Apa yang present tadi ada, except one guy lah yang text me.
Okay, Doktor. Thank you.
So nanti tolong beritahu kawan-kawan yang lain.
Okay, Doktor, boleh.
Ini dah tahun 3 ni. Kalau tak ada nak bangun pukul 9, which is very dark lah for you. Bukan yang ada kat sini lah. Your friends tak banyak jadi engineer nanti. Okay, thank you very much. So nanti kita jumpa on this coming Friday. Okay, Assalamualaikum. Have a good day.
Okay, Assalamualaikum semua.
Waalaikumsalam, Doktor.
Assalamualaikum, Doktor.
Terima kasih, Doktor.
Thank you, Doktor.
Thank you.
Selamat pagi.